Okay, what we're commencing here is new paralever pivot bushes replacing the pinion pivot needle rollers here. They're the originals. They're being replaced with pinion pivot bushes. The old pinion needle bearing rollers are being replaced, and they're being replaced because the new bushes, which are quite popular lately, have here a little Allen key which you can remove and fit a grease nipple on either side. On inset and outset, they will have a grease nipple that can be fitted for you to grease these troublesome pinion pivot bearings without wheel guard final drive removal. Saves a lot of time and effort. Okay, so our next step will be using, this is a pointer, we will remove the guard. There's the Allen key removal there. If you have a look up underneath here, there's the other one. So we remove that. We then remove the caliper. Okay, there are two 8mm bolts, socket head bolts, there and there. But before you remove that, you must remove, if your bike is fitted with ABS, this ABS sensor. And it's not a socket head Allen key, it's a Torx bolt. With the caliper, there is no need to disconnect the rear brake hose. Do not disconnect that. And if removal is hard, you might have a lip here on your rotor. So what you need to do, once removing the bolts and the sensor, is rock that caliper from left to right, and the pistons, the dual pistons, will slowly retract and move towards their seat, allowing clearance between the two brake pads to get up over the lip on the rotor. That's if you have considerable wear on the rotor. You then hang the rotor up to here with a cable tie. Hang it up out of the way, giving you enough clearance to work as the stages progress. Now what I will do when removing this sensor is, in there you can just see a lot of shims. There they are moving there. Okay, I tape that up. I just put some tape around there. It keeps the bolt, it keeps all those shims in situ. It keeps them where they exactly are. And then of course, remember, when I remove the caliper with the two 8mm mounting bolts underneath there, it's all suspended, secured up here out of the way. Okay, so once we have the rear guard removed, remember it had 3 socket head screws. These 2 are larger than that. This one's smaller than those 2. So you have 3 to to mount this. Then we've removed the two 8mm caliper mounting bolts from there to there. And remember, before you remove that caliper, you must remove this sensor if you have ABS fitted to the bikes. So what I've done is I've just put a little cable tie there, and it keeps all those shims in situ, and I just suspend it through there on the rear pinion peg mounting bracket. There's a little provision for it there, just slips in there and rests. So that's where we're up to now. The next step will be to remove this wheel, which we can clearly do. We have clearance now because the rotor has been removed. Now the next step is, but not now, I'll be taking it off the center stand and putting it on its side stand so I can load up this rear wheel, and with the weight of the bike I'll be able to remove, using the weight of the bike with the wheel on the ground, I'll be able to remove 1, 2, 3, 4 wheel nuts. All right, to remove the 4 wheel nuts, I suggest you find a good breaker bar. It's a 17mm socket, an extension, and a good length breaker bar. And of course, when we put them back on, everything has an appropriate torque. Must be torqued down with a torque wrench so as you do not risk stripping any of those 4 threads. If you strip any of those threads, you've got a fairly complex situation, fairly complex repair on hand, and we don't need that, and we can avoid that with the proper torques of all these bolts that you come across during this operation. We'll now proceed to take the bike off its side stand and place it on its center stand. Remember, it was on its side stand to put the load of the bike, the weight on the bike, a weight transfer to that rear wheel on the ground, so as it gave us ample purchase for the tension required to undo those bolts. Now, before we go any further, what I'd like you to do, once that rear wheel comes off, you do not want to risk this bike lunging forward off that center stand. Because remember, you'll have no rear wheel once we take it off. And if it falls over, you've got a big job getting it back up. And not only that, it can cause some serious injury if you're nearby. So what we're going to do to ensure safety in our workplace is we're going to get a ratchet strap, and you will tie it around the back of this center stand and in and around here, somewhere around, if you look at that wheel, it's 12 o'clock, 3 o'clock, 6 o'clock and 9 o'clock, sighting it from the right hand side of the bike. We'll put our ratchet strap around here. That way it clamps the bike and it will not allow that center stand to retract back up to its restful position and prevent the bike from falling over. Very important. Okay, once we have that rear wheel off, we can, at this stage, conduct an inspection of the final drive's main bearing, which is the largest one. I'm sure you've seen it on part supplies like Moto Bins and Munich Cycles and Maxes and Beamer boneyards, whatever they're called, or wherever you source your parts. So this here, just see where my tip of my Allen key is pointing? That there's a seal. So what you do is you just go all the way around there and inspect. Now, that sort of is okay. There's no leaks. There's no drops. Okay? So that's not leaking. So far, so good. Another way of testing is up underneath here. You have a drain plug, a final drive drain plug. So when you're changing your oil, it has a magnet inset in the center of that drain plug. And what you look for is any silver or gold dust or chips, which pretty well insinuates some associated wear in the final drive. This one here, its final drive fluid was changed recently and it was surprisingly clean. For 90,000 Ks, that's not bad going for one of these final drives. But I always say it's about maintenance. Now once I get to this stage, I have a personal test to test these paralever, pinion, pivot, needle roller bearings, if you have the original ones, or if you've in the past replaced them with rubber chicken racing phosphor bronze tapered bushes. Either way, or either application, no matter what you have, what I do is I grab that with the palm of my hand and I push up in a 12 and 6 o'clock fashion. I push pull, right? And I also push pull in a 3 o'clock and 9 o'clock fashion, exposing any play. Now, how you eliminate play from the final drive output to the wheel and the paralever pinion pivot bushes or bearings, how you eliminate that is when I put one palm, usually my right palm over there, I move that up and down whilst with the other free hand, this is whilst I'm not videoing, of course, I put my finger on there, my index finger. And if there's any movement here, I can usually feel it being transmitted through to the end of what they call paralever pinion pins. Now this one's the lock nut. This is the adjustable side. And the other one is just a fixed pin with a thread. This is the adjustable one, but there's two pins, one on this side, inset, and one over there, outset. And you can feel by getting that, moving it up and down in such a fashion, if there's any play, you'll feel it being transmitted through to the source of movement. If there is, in fact, movement in these paralever pinion pivot bearings or bushes. Hope that makes sense. That's a pre-check before you get there. But the better check, of course, is with the much larger wheel on before you get to this stage. But with the wheel, I can find it's a bit awkward isolating movement here and or over there, because the wheel over here obscures access for the pinky to be placed on that pin and actually feel the vibration being transmitted. Okay, I had commenced to pull the bike apart in preparation of a parcel to arrive containing the new paralever pinion pivot bushes. And just so happened that today through the post they have arrived, and referring to earlier communication, here are the detachable grease nipples that fit into, see the socket head inset in the center there? You remove that, you fit the extended grease nipples into there, and you can grease them without all this complex disassembly. How good's that? It just streamlines maintenance procedures. It reduces time, and it also reduces costs on the long term. So that one there, of course, is the outset replacement here. Rotate that. That one there is the adjustable lock nut pin located inset on the other side. We'll get to that fitment, but the next step here is just undoing a few clamps. Be very careful with these, they bend very easy. So they're your final drive to paralever. Clamps. Okay. Now the next step gets somewhat more interesting. What we need to do is remove the outset pin, this one, and the inset on the other side. So what we do is we must heat them. Why do we heat them? Now the reason we heat them is because traditional methods, fitment methods, have it that Loctite, a high strength Loctite, is applied to the threads. A BMW at one stage, and I think they did it for warranty purposes, applied Loctite 270. Now if you do not heat these with MAP gas, you risk, or you most certainly will destroy the threads. So heat them, and I usually take them up to about 210 degrees Celsius, so as that Loctite 270 high strength breaks down. It releases with the heat, allowing you, through purchase and tension on a good size breaker bar, to release, to crack those threads open. Do not attempt to undo these without heat. Otherwise, you most certainly risk destroying the threads in the aluminium paralever casing. That goes for both sides. And where you direct this flame the flame tip is strongest at the tip of the blue, not the light blue. At the tip of the light blue flame, it's where most heat is generated. And you direct that tip into here. Why do we direct it into the center? We direct it into the center because then it dissipates in an outward fashion. Don't apply it around here, otherwise you'll burnish all that. You'll discolor it, and it will look very, very unattractive. It'll be an eyesore. So direct your heat into the middle. Now before we proceed with the heat, you've got to remove this rubber boot, the final drive to paralever rubber boot. You've got to remove it from, separate it if you like, from the final drive end of this paralever. Separate it, because the heat that's being generated there may burn and distort this rubber boot. So I push that back here and put a cable tie around there and a cable tie around there. It all bellows up like a bellows, it contracts, and I have a good 1-inch gap from there to there. Also, when you're removing this or peeling it back, it's good to have a bit of a look down the bottom. And what are we looking for? We're looking for oil down there. Mine's quite dry. Okay? Now that being the lowest point here, you'd have seen oil if what's called here the final drive pinion shaft input seal is leaking. You'd have seen oil dripping down onto the ground from the lowest point of this boot. See that? My pinky's dry after having touched the bottom. So I've got no leak at the final drive input seal, and I've got no leak, as we checked earlier, on the output side, on the wheel side of the final drive either. That's a good sign. And it's also quite promising because look at the list, look at the tilt. That's downwards, follow it upwards towards here, your swing arm, and further is the output shaft of the gearbox. There's an gearbox output shaft seal there, and if it was leaking, it would run down the paralever, come swing arm, tunnel, and pool down here. Okay? Now, before you start to heat, I would have at the ready the Allen key that fits here. I would have that ready with a breaker bar. So as soon as you get up to temperature, 200, 210 degrees Celsius, or heating for at least 3 minutes with the blue tip in here, I would have the tools at the ready so as you can remove the heat and grab the tool, fit it, and crack it open. You just can't heat it and then go away looking for your tools, because you're going to lose that heat. So have everything ready so as when you remove the heat, you can fit your tools within a few seconds, a few split seconds, utilizing the optimum heat to crack that thread open. And in addition to that, removing this anti-clockwise, once we've satisfied all those procedures before we remove it, get a bit of support. Get a block of wood from ground to here even lift that up and fit that block of wood underneath there, because with a breaker bar anti-clockwise there's going to be considerable load placed on that thread. And we don't want to, with such tension, high torque tension, distort the paralever or bend it in any way. We need a block from here, ground, up to here to support it, and it's much easier to remove these in situ, okay? But it needs the support. So there we have the blocks in situ to support that tension from the breaker bar for removing this pin. So to keep this rubber boot, final drive paralever rubber boot, away from the heat, the source heat, you have diagonally 2 shoelaces will do. There's your anchor point there, strapped around there underneath. The other one saddles it from the drain plug, that's the tie point, up over the top. So you have this diagonal separation, if you like, okay? So that's the concept there. Okay, so I've just removed the right hand pin, paralever pivot pin, and its associated bushing, and looking at that, I suspect it's the rubber chicken racing bushing. No longer available, but available for quite some time in past years. A bit too hot to check out the smoothness of the bush. That's the phosphor bronze bush. It does appear to be well greased, no problem there. So make sure you heat that as described earlier for 3 minutes, at least 3 minutes. That should take it up around 200 degrees Celsius. If you don't, you're going to obliterate those threads. They're your steel ones, they'll survive. But the bond, the Loctite bond that's created from steel to aluminium, if you don't heat it, if you attempt it cold, it'll take all those aluminium threads off, and you'll be in big problems. Yeah, you'll complicate the issue there. So now, with that same amount of heat, I'll undo the lock nut and adjustable pin on the inside. Okay, after having removed the outside pin, we now will commence to heat this again in the center. The heat will dissipate outward. The heat transfer will radiate out from the center in all directions. It's a good equal disbursement or distribution of heat, always from the center. If you haven't got a thermometer to a heat sensor, heat sensing gun, just heat it for 3 minutes. That'll get you up around about 200 degrees C, 210 thereabouts, all right? And remember, making sure that your boot is still secured and away from the heat, the more intense heat, keeping the flame in here, and having the tools. In this case, it will be a 30mm socket for Mr. Locknut over here. That gets undone first, and whilst the heat's there, quickly, as soon as you can, I'd even go for another, after you undo that, crack that open, I'd apply another 30 seconds heat, get that back up to the optimum temperature, claw back the heat that you've lost from there to here, and crack that open. Remember, have your tools here. That's for the pin, that's for the lock nut, and there's your breaker bar. Have them at the ready, so as when you complete the heating process, you're ready to do what you need to do. Okay, so now both paralever pivot pins have been released. We're just looking at those threads in there. They look intact. They're the important ones because it's the softer aluminium material. So they're fine. And I've also inspected the inset ones. Some focus there for you. A bit hard. But anyway, they're fine. So that's why we need the heat, so we don't strip those threads, especially with 270. Some purport to put, you know, some purport that that strong Loctite is not needed, but I always err on the side of caution, and I just do what a BMW did from the get-go, 270, and it releases well with heat, and you feel a whole lot more secure riding up the highway, knowing full well that those aren't going to let go. Okay, so once we've removed the pins, the paralever pivot pins, or the bearing or bushels, we now come down here and remove that bolt. The nut is inset, the bolt head is on the outside, outset. Okay, we remove that, and the reason we remove that from the stabilizing bar and the paralever turret is so as we can remove the final drive assembly from the drive shaft turret. What we'll commence to do is, you can just see it there, I'm pointing at them, that's the outer race. That's the outer race that's pressed into the final drive joint, spline joint. Okay, so when we get to this stage, before we remove it completely, I'll get up there and mark that drive shaft position. So as this goes on back into there, that spline goes up into the female spline of the drive shaft in exactly the same spot. All right, before we remove it, I'll just get my pointer. You can just see through there the drive shaft end, or yoke if you like. Don't let that slide back and out. Don't let those splines separate, because if you do separate them, you can get in there and grease them if you like. If you do allow them to separate, you'll have to rephase your drive shaft. The drive shaft is what's connected up the other end to the gearbox output shaft, and extends all the way down through this tunnel and connects to the final drive. So don't let that yoke, or if the end of the drive shaft, separate, otherwise you'll have to rephase the drive shaft. So you can go online and look up what rephasing is, but just keep that in situ, just be mindful. You can also utilize these holes here, being careful not to burr the threads, and keep that in situ. I suggest with a piece of dowel or wood to prevent it from sliding all the way back and out. That's when you're removing the final drive assembly from here. Now what I've done is from the outer race inset, what I've noticed is, taking my finger around there, is I'm getting this sort of bronzy, greeny coloured grease, which tells me that the phosphor, I don't know if the colour's going to be vivid enough for you to pick up on it, but you can see it there. That grease is supposed to be black, but it's now sort of, it tells me that the phosphor bronze bush was starting to wear, and its wear is contained in the grease. It's completely discoloured it, and when I actually checked the phosphor bronze bush, there was a degree of galling there, and it was nowhere near as smooth as the outset bush. The outset bush still had grease, which was black in colour, but this here tells me that there are now phosphor bronze particles contained in that black grease. It's no longer black grease, it's now been discoloured. So I'm, come in at the right time here to replace it with the serviceable bushes, where I can get in every 5,000 Ks and just grease them up. They've been in there for about 15,000 Ks. The service was just about due, but there's considerable wear before that maintenance interval. So very fortunate I've gotten in there and done this at the point that I have, as I'm just about to go on a, there you have it. So now that we have the final drive removed, what we're going to do is we're going to remove the races, the outer races that were paired with the Rubber Chicken Racing Phosphor Bronze inset bush. Now, these are removed from, you put a driver or a dolly all the way down and do the bottom one first, support it by any means, preferably wood underneath, and you aim for this edge here. See the top of the thing is resting on that? Because you drive them outwards to the outer, in the direction of the outer extremity of the yoke. So that one there gets driven down, you invert that and you drive this one in this direction. You drive it in the direction of the outer extremities of these both surfaces. Drive them out. Don't attempt to drive them in, because you'll destroy the housing. This assembly will be destroyed. Okay, now the next step is to drive out the, as you can see there, the old tapered races. So in this position, we're going to drive out the bottom one that you can see through there. You'll see the lip, you'll feel it. See there? Okay, so we've successfully removed the outset race. That's the right hand side of the bike. If the final drive is fitted to the bike, that's the outer extremity, the exposed side, the outset side. So as you can see, I've effectively removed the outer race. And what I can see here is a little bit of associated wear there, but it's much better than the inset race. Okay, so what we'll do here is we'll get our faithful little map gas again, heat it, nowhere near the extreme heat that we use to get the pins out initially, but we'll apply some heat in and around here, and that will expand that. The heat will expand it, and then we'll drop. Now, being the outside one, it's that one there. It's that one there that goes in. So we'll remove that outer race there, and whilst that's hot after heat, it will just drop in there and work its way all the way down to that seat there, that ridge that my fingernail is touching. Once that's seated, we'll invert it, then knock out the outer race there and insert the next one. Now, just quickly, it's very important that you keep these mated surfaces together. It's most important that you keep these mated surfaces, the pins and the bushes, paired. Keep them together, don't separate them. Keep that bush paired with this pin. Don't put that bush over there with that pin, that bush over there with that pin. Okay? Keep them mated, keep them paired, don't separate them. So I suggest when you get these blister packs, do not open the blister packs until you get there. Otherwise there's a chance of getting them mixed up. Okay? Don't separate them. That way you'll keep them paired whilst you're fitting them back into situ where they belong. I also suggest, before fitting the outer races, the new outer races for the new bushes, that all this surface around here gets cleaned up with a solvent, brake cleaner, to get rid of any oil residue or any oil film in there. That way the outer race will have a better grip, a far better grip, and there's less chance of it slipping. Being an interference fit, it's highly unlikely, but getting rid of all that oil between the outer race surface and this assembly assists greatly. Okay, so we've driven in that pinion pivot, the outer edge, outer extreme, exposed sides, that's that pin there. We've driven in the outer race bush combination, and what you do when you're doing that is just use a socket that sort of, don't come anywhere near the phosphor bronze bush, but pick a socket that hugs the outer edge of the bush. So that one there is perfect for this operation, and hit it at 12 o'clock, 6 o'clock, followed by 9 o'clock, then 3 o'clock. Okay, just tap it. I use a half-pound hammer, and I hit it there, then there, then there, and then here at 3 o'clock. A couple of taps, light taps, don't go overboard with it, okay? And you'll see it, position it there evenly and true. There's a bit of a taper there for it to commence, and keep on going until you'll hear that solid sound once it seats and bottoms out. But that's the finish there, and it's just a slightly raised edge, an equal raised edge all around. Not very high at all, just a very slight half a mil, if that. Now we'll proceed with the inset one, the one down here. So we'll just turn it upside down and commence that same procedure. Okay, so both pivot bushes have been placed by way of drift using, as I said, a socket that's of smaller circumference on that outer edge, and just drive that in. Use an old socket preferably, not one of your snap-on high quality ones. Brass doesn't send it home like a steel ball peen hammer does. Brass, those that are mechanical fitters would understand that, but the steel hammer seems to work best. The shock wave just transmits more sharply and drives the bush. It's an interference fit. Okay, remember we had to heat up this area here, heat, expansion, and the bush of course is cold, so it goes into place with less resistance. There's still some resistance there, but as it cools, all that tightens up around the outer edge of that bush race and just allows the pin to move freely in there with its greased component while the bush itself remains fixed. And there it is. There's the bottom one. It's been fitted, and the top one. So remembering that we kept these paired. So that outer one there fits into there. And look at that beautiful sliding fit. You can actually feel the vacuum that's being created, the suction, as I draw that back out, the compression and suction. That's a nice fit. We'll get on to the next stage where we'll grease the pin, shaft, and the inner diameter of the bush itself with the supplied grease. These kits for R1100GS are available through Munich Cycles, where I purchased this one from, and of course you're able to get them from other outlets across the pond like Motto Bins and Motto Works. A very good concept. You can throw those paralever, pinion, pivot, needle bearings away. You get a lot of Brunelling from the needle rollers into the outer race because the shaft itself only rotates about 15 or 20 degrees depending on how bumpy or irregular the road surface is and how far your rear shock, monoshock, is compressing. They were designed to rotate 360 degrees, not that much. And that's why those needle rollers were very questionable. Okay, well now that we've fitted those the bushes and kept them paired, taking note of which bush belongs to which pin, as I mentioned earlier, we will now commence to fit the final drive back onto the bike. And of course, before we fit this final drive, we will take this exposed opportunity, now that everything's exposed, in particular our dear friend down there, splines, and up the other end, on the end of the drive shaft. We'll lubricate those. I'm quite fortunate. I'd only just done those recently, but I'll do them again whilst opportunity presents. Okay, so I've just positioned the final drive back onto those blocks that we used to remove the final drive. Okay, so what we have to do is line these up with that, and we also have to get that yoke there at the end of the a drive shaft onto that spline there. Look at the output shaft spline on the input shaft spline, sorry, on the final drive. What I do is, when you come around here, have a look, I put 2 bolts in there. That helps me rotate this way and that way. And it's a bit of fiddling. Sometimes it happens quickly, sometimes it takes some time, but you just got to persevere. Once you get it in, slip those pins in. Once they're in situ, we'll apply Loctite to the threads, 270, and it does go off quite quickly. So you've got to have your torque wrench there with 105 Newton meters to torque it up. Okay, I'll get to that when we get there. But at this particular time, we'll just line that up, put the pins in loosely before we get to the torquing. All right, after some perseverance, we've got the input spline shaft, final drive input spline shaft into the drive shaft from the final drive down to the end here. Make sure that that drive shaft is phased. BMW put distinct red dots up one end, another red dot down the other end. And you just look up the tunnel, might need a fairly focused, nice bright white light shining up that way to ensure that the red dot up there and the red dot down here is lined up. You may need to rotate it to find that red dot, but you will find it. But the hardest part of the whole exercise, I find, is lining up the final drive input spline shaft with the drive shaft. Now, I've just put these pins in loosely. I haven't torqued them up, but I've just put them in for alignment of the final drive. So what I will do is I'll remove this and I'll have the torque wrench. Always have your tools at hand. I'll have the torque wrench at hand and I'll apply Loctite 270 and I'll tighten it up to 105 Newton meters. That's for the fixed pin. And over there, the adjustable lock nut pin. You can just see him on the inset. We'll get to that also in the next video. So, you know, like I said in previous exercises, those bushes and the pins were lubricated with the black molybdenum disulfate grease that was supplied with these bushes. You can see the Allen key in there, like I explained earlier on. They're removed and elongated grease nipples are applied there. So it does away with all that hard work, let me tell you. Oh, just a streamlined process. It makes it so much easier, but we're nearly there. And continue on in the next video when I lubricate those once again and torque both pins down. All right, so just recapping, these are the grease. You can grease these pin bushes, okay? They have a socket head there. You can remove that, and when the kit comes a attachable and detachable grease nipple and extended grease nipple that you can actually grease these pins both outset and inset with molybdenum disulfate black grease. Now, I've actually put 270 lock pins, Loctite on these lock pins, 270, Loctite 270 on the threads of both lock pins and on the thread of the lock nut. And I have tightened the fixed lock pin, which is outset, to a torque of 105 Newton meters. Now on the inset, this lock pin there, you can just see it with my fingers pointing, the inset one, the lock pin has a 0 end float, 0 play. So you tighten it up until it touches and bottoms out. Don't be monkey fisted with it. It's just 0 play, 0 end float. So you just tighten it up by hand until it touches and bottoms out, and then using a cutout socket and an Allen key or socket head wrench, if you like, holding the socket head wrench with the pin fixed whilst rotating the lock nut to 105 Newton meters. Okay, so while you tighten that lock nut, you should index both lock pin thread and lock nut with a bit of white paint, so as while you're tightening the lock nut, you ensure that the lock pin that has bottomed out does not turn any further. Okay, it's just 0 end float. It's not monkey fisted tight. So the lock pin on that side stays fixed while you're tightening the lock nut. So it's the lock nut itself that gets tightened to 105 Newton meters without the lock nut pin moving. All right, and once you do that, it's just a reverse of that initial disassembly, putting the wheel back on. Now your wheel nuts are initially in a crisscross pattern taken up to 50 Newton meters, and then the final crisscross pattern for the wheel nuts is taken up to 105 Newton meters. These caliper mounting bolts, I usually apply a little bit of blue Loctite on those and then tighten them to the prescribed torque of 40 Newton meters. These little ones, if you have ABS, these fine, small, I think they're 5 or 6 mil threads, they're only about 8 Newton meter torque, 8 Newton meters. And yeah, about 8 Newton meters on these little ones holding the plastic guard if you still have them. Okay, so there you have it. And when you're tightening up these here, don't tighten them up too tight. You'll feel the rubber. You'll just feel that compress, go about 2 or 3 more turns and leave it at that. So I hope you've enjoyed my video. I hope my communication skills have been formatted in such a way that you understand them. Look, I don't know the skill set of people out there. You know, some are more skilled than others, hence me being very explicit in detail and communicating the most basic of all steps. But there you have it. That's the R1100GS replacement serviceable pin bush configuration that's available from Moto Bins and Munich Motorcycles. Moto Bins in the UK and Munich Motorcycles in West Oz. And I think that's a brilliant concept, because you don't have to dismantle the final drive and go through all those laborious tasks of simply lubricating bushes or bearings. All you have to do here is unscrew that Allen key, attach your grease nipples, which come with the kit, and grease them up. And I do it every 10,000 Ks, you know, 3-4 pumps at the most. It's only a small area with a tight tolerance. Any excess, yeah, will come out and dislodge itself into the tunnel, the drive shaft tunnel, come swing arm. But a brilliant concept, a one-stop shop without the labour. Thank you. Please subscribe to my channel and send a few likes my way. All the best now.